make sure the meeting is recorded. Okay, good. So kindly indicate, is my screen visible and my audio clear as well? Is my screen visible and my audio clear as well? Okay, thank you for that indication. I think we can start. Okay, so this is one of the reasons I keep encouraging us to attend to attend all the meetings, because if at all network in Copala is quite difficult or quite tough. So if I tell you attend a meeting like this, at least you have somewhere to start. You go and read the notes, then we upload later when the network is a bit stable. But I think we will do justice very, very soon. Okay, so here is us about the relational data model and relational database constraints. Okay, so in our previous meeting we have shared, I think we talked about what modeling is basically building. Give me a minute. Famlenga Wada Kalebu. I'm having a class right now. Okay. Sure. Keep you posted. Okay, so thank you for that. Model or modeling is building. Okay, then constraints are rules. I think we've forgotten an aspect. Please get where to write. Please get where to write. We've given each other a minute, and this is 53, so 54 we start. Get where to write. Just indicate when you get where to write so that we continue. I'm muting myself.
For a long time, lecturers and staff members at the University of Zambia have been holding press briefings and protests demanding for their dues, which include pensions and gratuities owed to them by the government. On 29th of June 2026, the University of Zambia Lecturers and Researchers Union, Unzalaru,
kindly indicate, have we prepared where to write?
On Thursday, 2nd June 2026, to demand settlement for long-standing terminal benefits owed to the lecturers and the retirees. In this accord, the Ministry of Education today announced that 450 million kwacha has been released to address the lecturers' gratuity and pension concerns.
The government has released an additional 450 million to address outstanding personal obligations at both the University of Zambia and the Copperbelt University. And I'm saying today, this money has been released as I'm speaking right now. These resources have been allocated as follows: 88 million to settle all outstanding pension and gratuity obligations for retirees at the Copperbelt University, 225 million to settle pension obligations for retirees at the University of Zambia covering the period 2021 to 2023, 137 million to clear gratuity obligations at the University of Zambia covering the period 2016 to 2020. These interventions represent an important step towards honoring obligations to former members of staff whose dedicated service contributed immensely to the
University of Zambia Lecturers and Researchers Union has welcomed.
Okay, thank you for that. So like we've always done, database constraints. So let us begin writing. Okay, data model or data modeling, that's the first. We will still make a recap. So when we talk about data modeling or data model is the building part. Okay, so database constraints. So I think let us talk about this guy here. Database constraints. Database constraints, please write database constraints are rules applied on a database. Database constraints are rules applied on a database. So there are these rules which we will talk about in a minute. Okay, have we written that? Can you give me a thumbs up so that we make the progress? Have we written that? Thank you. So overview, so the relational data model, it was introduced in 1970. Please go ahead. Okay, data constraints, database constraints. Database constraints are rules that applies on a database. Constraints are rules. Rules that apply on a database. Quite important there. Is that fair now? Okay, good. So overview, this relational data model was introduced in 1970. Based on set theory, you have this in your third year. To do with advanced database, don't worry about the set theory, periodic logic. Using mathematical relation similar to table values. Do not worry about these, you have them in your third year as its basic building block. So the first commercial implementation appeared in 20th century, which is 1980s, such as IBM, SQL, DS, Oracle, and right now we use Oracle for that. Okay, so today popular relational database management systems includes DB2. Okay, so it is database 2. There is Oracle databases. There is SQL Server, Sybase. I've never used Sybase though. There is also H2. I think I've used H2. The open source systems like MySQL, and PostgreSQL. And by far, PostgreSQL is the best, by far. PostgreSQL. So we will look at the foundational principles of relational model, including its modeling concepts, relational constraints, update operations, and integrity constraints. Don't worry, we'll dive deep into these. I think these will be our focus. Modeling constraints, relational constraints, update operations, and integrity constraints. Okay, please pardon me for that. So, relational model concepts. So, let us just look at a few concepts there. So, relational model represents database as a collection of relations. Okay. Now, when we talk about relational model concepts, remember, if you forgot this, you better rewrite it because we did talk about that. A relation is a table. Do I have that? Give me a minute. Okay, not right here. Okay, don't worry about these. We'll come and talk about them at a later stage. Okay, if you can see my cursor, can someone indicate which one are you seeing between relational model concepts and introduction to SQL? Which one are you able to see?
Relational model concept.
Good. So let me just do this. Okay, so are you able to see this now? Are you able to see this? I can't see your thumbs ups. Okay, I can. Okay. Okay, good. So this is a relation. So this is name and a table is called a relation. So a relation is a collection of the name and the table itself. Please, if you are writing that, you can write. I know this is a bit far, but we want to make sure that you understand what's going on. A relation is a collection or a combination of a name and a table. That is quite That's quite important to establish. So this name you are seeing here, it is called a relational name. Thank you. So this is called a relational name. Quite important there. So this is a relation, the combination of a name, which is a relation name, and a table is called a relation. This is a relation name, and this is a table. So the combination of a relation name and a table is called a relation. Now, am I too fast, or you've written that? Am I too fast? Okay, good. Now, there is this relation and this relation. Please take note of that. There is this relation and this relation. Remember, the collection of a name, of a table, and the table itself. The collection of the name of a table and the table itself is called a relation. Please go ahead. You can't see my cursor? You can't see the screen?
The screen I can see. It's there, but it's not moving.
This is not moving?
Okay.
Okay. So you can see this now, right?
Yeah.
Okay, good. So a relation is a combination of the name of a table and the table itself. That's what we are saying. So there is this table and the name. There is this table and the name. So the combination or the collection of a name of a table and the table itself is called a relation. Does that make sense now?
Yes.
Okay, good. Yes. Written?
Yes.
Now, yes. I want you to take note of this because we will be leaving this screen. So there is this relation. So when we talk about a relation now, you know what a relation is. So there is this relation, there is also this relation, there is also this relation. Now, I'm sure you can see that. Now, relational model. Okay? Relational model is now the combination of the relations. You saw what relations were. So we had the relation, the name of a table and the table itself. The name of a table and the table itself. So when you get to relation, that is what we are calling relational model. So I hope you can see my cursor. So point number one. So relational model represents a database as a collection of relations. Does that make sense there?
So can you repeat?
Relational model. Okay, I think I should get back there. Let me get back. Relational model. You know this is a relation. This is a relation.
Yes.
So a relational model is the collection or putting together different relations. So when you get this relation, you also get to this relation, you also get to this relation, you also get this relation. You've seen this relation goes there, this relation comes here, the other relation goes there. So you see how these relations are connected. So this relation is connected there through that. This relation is connected there. This relation is also connected there, and so on and so forth. So that connection or that putting together of these relations is called relational model. Does that make sense?
Yes.
I know that will come at a later stage, but we will use that as the way of building our foundation. So, relational model represents a database as a collection of relations. That's what we're talking about. So, each row in a relation, which is a table, remember, a table is a relation. And a name of a table is called a relational name. That's why we are saying a relation is a relation and the like. So, represents a collection of related data. So, each table will only have the data which is connected. If it's the table for students, you don't find the lecturers to be there. If it's the table for lecturers, you don't find the students to be there. That's what it means. Each row represents a collection of related data. That's what we are saying. So in a row, you would find if the name is John, the age will just belong to John, the student number will just belong to John, and so on and so forth. So each row represents the collection of related data. That's what we are saying. I think this is not the first time we talked about this. So informational, informal relation model terms, a row is called a tuple and a column header is called an attribute. Table is called a relation. So we come here, okay? Remember what we said. I think we built a very solid foundation to this. We have a student. A student is called what? I think we talked about this. Let me ask. An entity. Thank you. Thank you for that. A student is called an entity. So this is a relation name. I'm sure we've talked about that. So this is a relation name. So please don't get confused when they say a relation. A relation is basically a table. And a table name is called a relation name. So this is an entity. Now, the characteristics that gives more information about an entity is called what?
Attribute.
Attributes. Thank you. So you'd find that this is an attribute. It gives more information about these students. So we need to know the name of these students. We need to know the computer number. For example, the computer number in America, those IDs are called SSN, which is Social Security Number. Home phone. What if we wanted to contact this student? We need to know the phone number, the address where they stay. If they have the office phone, if they have what are their age, what is their GPA, and so on and so forth. So these column headers, they are called column headers. So this is a column, this is a column, this is a column, but this is the first row. Is called the header. So these column headers are called the attributes. Okay, so this is a relation name, and these are called the attributes. And this is what we are saying here. So a column header is called an attribute. Attribute there. Okay, then the table is called a relation. A row is called a tuple. Okay, so we are now changing the language bit by bit. So a relation name, attributes, then these rows, row number 1, row number 2, row number 3 are called tuples. So these are tuples there. Okay, that's quite important to establish. Are we good? Kindly give me a thumbs up, otherwise give me a question. Only one thumbs up? Okay, good. That is quite important. So relational model is a collection of relations. Now there are concepts related to that. Those concepts are called domains, attributes. We've already talked about what attributes are, tuples, relations. So here we haven't just talked about the domain. We will. Okay? And it's not complicated. Attributes, characteristics that gives more information about an entity. Tuples are rows. Relations are tables. Domain, remember, let me present this again. Remember, I think we all of us attended this. Remember, we broke down this guy into everything that we need. So we talked about the types of attributes. So there are those attributes that can't be broken down further. What do we call these attributes that can't be broken down further? What do we call them? Can someone please unmute themselves? What do we call these attributes that can't be broken down further?
Single or atomic.
See?
Single or atomic.
Simple.
Oh.
Please don't confuse the two. Single is when we remove all these. We remove sex, we remove that, then we remain just with SSN. So when we have only one attribute associated with an entity, this attribute is called single. But these attributes that can't be broken down further are called simple attributes or atomic attributes. Now, when you get this attribute, you put them together, you make a set. Please go ahead.
You said attributes that cannot be broken down further.
Simple. Oh no. Please correct that. I'm sorry about that. Then I meant simple. Single attribute, we should then correct that. Single attribute is when we remove all these other attributes here and we just remain with one attribute. When there is only one attribute, per entity, that single attribute. Please just correct that, my bad. Okay, good. Thank you. Sometimes you may not realize that you are saying something. Yeah, that was a bit carried away. So when you get these simple attributes, okay, you put them together, you form a set. Okay, so a set of atomic attributes. I hope you are writing that. A set of those atomic attributes is what we are calling a domain. Okay, so a domain is a set of atomic values, meaning domain is indivisible. Indivisible means it can't be broken down further. Are we good there? Please go ahead.
Sorry, I didn't get you when you talked about specific attributes.
Simple attributes are attributes that can't further broken down. Let's, for example, the name can be broken down into the first name, the middle name, the last name. Name itself is an attribute because it gives more information about you. But this name can be broken down further into the first name, the middle name if at all it's there, and the last name. Now, can a first name be broken down further? So that attribute which can't be broken down further is what we are calling a simple or atomic. That's the other name used. Atomic attribute. I hope we've gotten that now.
Yeah.
Okay, good. So now, when you get those atomic attributes and put them together, so a set of atomic values is called a domain. Meaning a domain is indivisible. Indivisible means it can't be broken down further. So domains are defined by types, and those types we were just talking about data types. Last time that we have had practical session, we talked about a variable character, for example, int, and so on and so forth. They are also called dates. Date for the date keeper, and so on and so forth. These can be appreciated further in programming, because when you begin programming, then you have to put in aspects. Do you want your application to store date? Do you want this and that, and so on and so forth? So those domains are defined by types. For example, the integers, the strings, and all what you can think of. Okay, including format specifications such as phone numbers, social security number, date, and so on and so forth. So a relation schema is a description. So a relation schema is a description of a relation. So you can have a relation called R, and this relation will have A1, A2, up to AN. A means the attribute. So a relation is a table, and this table have attributes. Like attribute 1 is a name, attribute 2 is the age, attribute 3, attribute 4, and so on and so forth. Are we together up to this point? Kindly give me a thumbs up before we make a progress. Okay, good. So, relation state. Relation state. Okay, so a relation state of n tuples. What we are saying is we have these tuples. N means the number of tuples. So you have 1, 2, tuples can be 2, tuples can be 3, and so on and so forth. So what they are saying there is for n tuples or rows, each representing an ordered list of values that corresponds to attribute in a relation. So each value in a tuple is from the domain of its corresponding attribute. Now, can you see my cursor? Can someone unmute themselves? Can you see my cursor?
Yeah.
Okay, good. So, a domain, of course we've said a domain is a set of atomic values. So, what we are saying in a relation sense, when you get a row, let's say this is a row, which is a tuple, then you also get to a column, which is an attribute. You get this tuple, then you say, okay, where an attribute and a tuple meets, that's a domain. So this is a domain. This is a domain. So for the name and the first row, they meet there. This is a domain. For the SSN and this row, they meet there. This is a domain. So putting together this, that, and that, this makes a set, which is that definition. So where an attribute and a tuple meets, that's a domain. Okay? And that is what they are telling you there. Okay, so each value in a tuple is from domain. So when you get a value in a tuple, which is in a row, is from a domain. Tuples, tuples are in order. Okay, you don't confuse things. There is order to tuples. So in those tuples, you have values. So you can have value 1, value 2, value n. So these are values in tuples there. So value 1, value 2, value 3, and so on. Okay. Now value just represents the absence of a value in a tuple. So do we have anything there? Okay, so when you look at this here, there isn't anything. Don't worry, we'll talk about this from practical point of view at some point. We just want to point out there. So represents the absence of the value. It's either the value is not applicable or the value is not known. In an example, you don't know the phone number for someone. you can't put it there. Okay? You know the address, you can follow them. The phone number cannot be that important. Or you can omit the address, you have the phone number. Of course, I would choose the phone number to be eliminated. Why? Someone can lose their phone, they lose their phone. Then they have a SIM. What's the purpose of having a phone number for someone who doesn't have a cell phone? Okay? It is either not known or not applicable. Okay? For the age, there are people who are ashamed of their ages. Someone will be asked, how old are you? What do you ask? It's a very simple question. So in that case, you can decide to leave out the age of someone. It is not applicable. How old are you? Is that even important? Other people would rather put the NRC number rather than the year they were born. So, for two reasons. The value can be now for number one, the value is not known. Number two, the value is not applicable. It doesn't apply. For example, HIV status. Not everyone needs to know the status of someone. Okay, so in that case, we shouldn't apply because that information is not for the public. I hope that's fine. Kindly give me a thumbs up. Is that fine? Okay, good. So we talked about now there ordering of tuples in a relation. So tuples or rows in a relation have no order. Okay, relations are not sensitive to tuple ordering. Not sensitive. And we'll look at this from the practical perspective. Ordering of values, remember, these are two different concepts. Ordering of tuples, which are rows. So for rows have no order. But values have order. What we mean is this. The first row can be the last. The second last row can be the first. So there is no order to how rows are put. Okay? But the values themselves in the row need to have order. Very important. Okay, so this is a tuple. T is equals to, then you have that. So for the name, you have Dick Davison, which is that. For SSN, you have 422. For the home phone number, there isn't anything there. So this T is tuple, this T is tuple. Okay. Now value, I think we've said that represent an unknown or inapplicable attribute. So the value is not known or the value is not applicable for us to have now value. Okay. So when we talk about relational model concept, relational model notation, so remember a relation schema is just a description of of degree of n is denoted by R. So that is a relation. You have the attributes there. Okay, like R here is a student, then the first attribute here is the name. Uppercase letter, lowercase letter. It's also important to mention that database is not case sensitive. So even if you say QRS represents a relation name, this is just putting an order. Okay, so we prefer using a relation name in capital letters, then using what is in those rows in small letters. What we mean is this. When you look at student, so this is a relation name, and you look at what is contained in this relation, small letters, small letters, small letters, small letters. Even if you write students in capital letters or small letters or combination, database is not case sensitive, but we just prefer using capital letters to make a distinction, to say, okay, this is a relation name, then in this relation, these are attributes and these are values. Does that make sense there? Kindly give me a thumbs up. Only one? Okay, good. That is what we are basically saying. So tuples, n tuples means we can have 4 there. N is 4. For example, if you can see my cursor, so we can have 4 tuples in that relation. Okay, and so on and so forth. We can also have multiple attributes. We can have a lot of attributes there. So in that tuple, which is T, okay, T is tuple, which is a row, we can have a lot of attributes there. So attribute, AW, attribute that. This is a row, okay, which is the header. This is a row there. So we can have this attribute, this attribute, this attribute, this attribute, this attribute, and so on and so forth. Okay, okay, relational model constraints, the rules, okay, though not important, we have these rules. They are business rules there. Okay, they are explicit rules. Okay, they are also implicit rules. Implicit rules are also called inherent. Then explicit rules are also called schema based. So implicit rules or constraints are rules that can be can apply on a database directly. Implicit, directly. Explicit, not direct, but they can apply on that database, but not direct. Okay, it's the same as implicit rules. Take it like there is a civil war in Zambia. That war, again, I know we are on internet, but this is what was happening when there was Kaderism, for example. As long as you are a Zambian at some point you come across the conflict which was happening, money gotten away from you if you are not beaten up. If you are not beaten up, money is gotten from you. You have this fear to move when there was gassing, for example. So you are affected in one way or another directly, because you know that at any point in time that would reach you. That is the same as implicit rules. So rules that apply on a database directly. Now, explicit rules are rules that applies on a database but indirectly. Okay? Indirectly. Okay? I know someone say these are constraints can be directly specified. Please get the explanation. These rules, implicit rules, are built in. Okay, they come with the database itself, are built in. Then explicit are not built in. You define those rules. You tell your database, okay, I want when this is done, this to be done. For example, you set your password. When you have that database, you set your password. It means you are saying only whoever has a password to my database can access it. So you specify, you choose which password are you going to use. That is explicit. Okay? So you specify. That's the keyword there. That means it is coming from the external point of view, not built in. Okay? Business rules, these are now can't be directly expressed. Okay? They can only be enforced through application program. So what we mean is, when you create your database, for example, or when you create an application, then you put it on these other applications for people to access. Okay? Let me give an example. Just a simple example. Each time you want to join, I say, okay, I restrict to say not everyone can join. I must let you in. Okay? Let's talk of Zoom. Zoom has a specific number of people that it can accommodate. Beyond that, it can't. So that is a rule which is put for publicity. And this is also the business rule. For publicity, you say, I want to enforce through application program. So when you reach this number of people to access you or your database, you can only store 20 people. I don't want beyond that. You can only store 100 people. I don't want beyond that. That is what we call a business rule. I hope that makes sense. Can you give me a thumbs up? Does that make sense? Okay, good. Okay, so the other rule are called dependencies. Okay, dependency is a very, very important concept that we are going to look at in the near future. So it is divided into functional dependence and multi-valued dependence. We are going to look at that in the near future, and very, very soon. We will talk about this at a later stage. So this is another rule, which is dependence. Okay. I think one example that I can use is the example of a relationships. Relationships, especially. I think this is why there are a lot of divorces, there are a lot of breakups, because we don't know what we feel. Simply because you can get support from someone, then you feel that is love. Sometimes what we feel is dependence. You can depend on that person, but you don't love that person. Okay, that is just a real life example. Okay. Constraints, domain constraints. Remember, a domain is a set of atomic values. So there is this rule which applies on those atomic values. So domain constraints ensures that each value in the attribute within a tuple must be atomic. So we are just saying is domain constraints just ensure that the values in the table are atomic. That's what a constraint, domain constraint ensure. Okay. Then of importance again is what we are calling key constraints. Okay. Key constraints is another value. So a key, for example, all of us have seen a key before, though nowadays you'd find that this key will open the neighbor's door. You'd find that behaves like a master key and all that. This key can start the engine of a neighbor's car, and so on and so forth. But keys are meant to be unique. So we're just saying key attributes just make sure that no two tuples are rows. If there are 3 rows, no 2 rows have the same value. So if in the same row, if in the first row there is an ID, second row there is an ID, third row there is an ID, these rows, these IDs must be different. That is key constraint. Okay. Now a super key, there is a key there. Okay. So a super key is now the combination of those attributes. Okay, the combination of attributes are columns. So when you put the columns together, that will guarantee the uniqueness of a tuple. That is what we're calling a super key. So coming here, you'd find that the name. 2 people can have 2 rows, can have the same name. Social security number is like an ID. So these are unique. Okay, addresses. Okay, no two houses have the same address. No two houses. Okay, or no two streets will have the same addresses. So you are here, but you are in, the address is Elgin Road. There are no two Cairo roads. There is only one Cairo road. So when you get this attribute and this attribute, you put them together is what we are calling a super key. Guarantees the uniqueness. Then a key is a minimum super key. So a minimum of these two. And so on and so forth. So you get this one alone out of this super key. So this one and this one makes a super key. Then you get SSN alone. That is a key. Or you get address alone. That is a key. Does that make sense? Kindly give me a thumbs up. Okay, where exactly should we repeat? On a super key? Okay. So, super key. You've seen this attribute here? Let's interact a little. Good. So, when this is an ID, can the two rows have the same ID? No. Look at the address. Can two streets in these two rows, can two streets have the same address? No. So, when you put these together, okay, the combination of attributes, in fact, if you are writing, you should write the combination of attributes that guarantees uniqueness.
Repeat the combination of what?
The combination of attributes, you know that is an attribute, this is an attribute. So the combination of attributes that guarantees the uniqueness of a key is called a super key. So from this illustration, this and this guarantees, the combination of these two attributes guarantees the uniqueness of a key. Okay? That is what we are saying there. Then a key is minimum super key. It means out of these attributes, you just get one. That makes a key. Where were we? Where were we? Okay. So a key is a minimum super key. Super key is a set of attributes that guarantees the uniqueness of tuples in a relation. That's very important. Then this key is minimum super key. Whichever you are going to choose. Okay, so in a relation can have multiple candidate keys. Okay, so getting back here, so this will have unique, at that point to be unique, that point to be unique, that point will be unique, that point will be unique, that point will be unique. Addresses, this point will be unique, 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 this point will be unique. Phone numbers can have the same phone numbers, but you you would find that no two phone numbers will be the same. Okay? Even phone numbers, no two phone numbers will be the same. But in Zambia, you have what you call +260. This is America. 817, 817, this is America. That sort code. So 260, 260, 260, 260, then these will be different. So you'd find that in spite of these being the same, since the other side are different, this is also, so the combination of this, this and that makes a super key. Now, each of these are called candidate keys. So a potential key, if you are writing, a potential key, okay, in which one are you going to have the confidence that it will not repeat? Not by mistake, okay? So in other cases, you'd find that even in NRICs, you'd find that two people have the same NRIC. In some cases, you find that two people have the same numbers. In some cases. But at the University of Zambia, no two people have the same ID. No two people. Okay? So, a potential key. So, if this is a potential key, it's called a candidate key. If this is a potential key, it's called a candidate key. If this is a potential key, it's called a candidate key. So that potential key, which you are going to choose among these keys, is called a primary key. Now, to put things into perspective, when you look at the phone number, a phone number, at some point, a phone number can be eliminated because it can't be known. You don't know the phone number for someone, you leave it blank. Address can be eliminated. You don't know the address for someone, you leave it blank. But for someone, okay, to guarantee that they are unique, social security number is important, or like an ID. So you'd find that this ID, one, it can't be now. Two, you'd find that it is unique throughout. So here is unique, here is unique, here is unique, here is unique, here is unique. Very unique in each row. And you can't leave it out. Okay? That is how we choose a primary key. Number one, you look at, if I leave it out, what impact will it carry? A phone number, you can easily leave it out. An address, you can easily leave it out. Even when we write assessments, they just tell you, even if you don't write a name, just write your ID. That's enough. So number one, it is not now. Number two, it is unique. And that is a primary key. Two characteristics there. So, we are here. So, primary key. So, a relation can have multiple candidate key. A candidate key is a potential key. And out of those potential key, okay, whichever you are going to choose is a primary key. The rest will be unique keys. Therefore, every relation or every table has only one primary key. The rest are unique keys. The two characteristics of primary keys are, number one, it is unique. It is unique in each row. Number two, it is not now. That means the value must be filled. And we'll look at this in a more practical way. Does that make sense? Kindly give me a thumbs up or unmute yourself. Sally, does that make sense? Okay, good. Okay, now constraints. So just to specify whether attributes have null value. That's what we are saying. Okay, let's see. Okay, so we shouldn't dive deep into this. We must look at the practical part so that we begin relating what these are. So we will end here. So that on Saturday when we have that makeup, we look at these and other things that we've looked at, so that when we say, okay, this is what it means, we've looked at that from practical perspective. Yeah, so someone to take note, we've ended on 17. Someone to take note, we are not rushing for anything. We have to ensure that you understand every concept of the way. Do we have a question? Do we have a question? If we don't have a question, kindly give me a thumbs up. Sally? Okay. So we meet on Saturday, 14 hours. We'll come to your inbox, Lisi, so that we set up your database. If there is no question, we are free to sign out. If there is no question, we are free to sign out. Thank you.